connector. And in this video I will continue on with the list of all of the components that are in the schematic. So I will go through the coils, and then hopefully we can go through many of these connectors as well. First we have L1. Let's see where L1 is. L1, and I'm gonna search for the whole word. Where's the cross? I don't see this cross. Where is it? Where's the cursor? The cursor that marks the component it found. There we go. So DC cal, we're not interested in that, so we'll search with whole word, and then we get this 100 microhenries, 3.64. Let's see, it's 1250, 3.64 amps, and then let's pick up this. Let's see. So we can search for it here. (100 microhenries and 3.64 amps). That's right. And 12.5, 12.5. But we also have to check the data sheet, remember, because some footprints can be can have wrong dimensions, especially if it's a component that's not widely used, like a resistor or a capacitor. If it's a component that's not widely used, we always have to check the footprints more thoroughly. So let's see here, where is the footprint? So 1250 I'm looking for. Is any footprint landing pattern? There we go. So the 1250, there is one 1250, it looks like this, and they're exactly the same. So this is the dimensions we are looking for. And the footprint that we have is worth WPD 1250, so we can open up this footprint and see. Sometimes I wish that KiCad had some kind of way to like not only better library management according to the workflow that I have here, but also that it would allow me to sort of mark components as like all good, green. So when I use a component and I get a board manufactured with that component and I see that everything works fine, then I want to mark that component as green to not have to ever review it again later. That would be very nice. And also something that also freezes the footprints, so that if my footprint library gets updated, I don't want to have to review my components again because the footprint library is updated. And I might actually write some script that will extract all of the footprints from the default libraries and place them into my custom library that goes together with my component library. I think that would be probably a better way to solve this. Anyway, I'm gonna open this footprint. It's located in my custom library. Let's see here. So there we go. So it's this one, and it has the distance between pads is 1390, which is 1380, close enough. and here it is 545, more like 540. Yeah, it's 550 there. I mean, this is interesting. So let's check this. 540 and 385. Okay. Yeah, that's close enough. And so what else can we check? Yeah, 385, and this is basically 385 because I already checked that. Yeah, cool. So this component is correct, and we can move on to the next. I'm gonna mark this one as green, and the next one is the 8 amps 2.2. Oh, by the way, I just want to check one last thing here. So this is TPS 54360, and this schematic, I got this schematic, I think, from the designer, the online designer for power supplies using this chip. So the 100 microhenry was the suggested value for this inductor. Okay, so next one is this one. This one is 2.2 microhenry, 8 amps, and it has a footprint that, let's see, yep, and it has a footprint that looks like this. This would be the footprint. Yeah. So this is what we want. Let's check the footprint. So find L2. Okay, and let's check the footprint here. Inductor SMD. So this is using Colecraft XXL 4020, and we could check that footprint and make sure that it's the correct one. Something tells me that there may be some differences, but we'll see. It's quite annoying having to close the other window and then go find the exact footprint. Let's see, where is it? Inductor SMD. And then it was, and now it's like, let's check exact name here. So I had the names in my list here. Colecraft XXL 4020. That would be, which one? Colecraft XXL 4020. Okay. And this looks like this looks a little bit like the one that we see here, but we could probably add silk screen around it as well, not just on the sides. But the most important thing here is the dimensions. So we have 0.98 times 3.4. So this one is, let's see, 0.98, 3.4. And this one is, let's see, 98, 3.4, that's fine. And the distance between them is 2.37. We can check this by taking 2.37 and divided by 2, so we get 185. That should be the position of each one of these. So this would be minus 185. Yeah, so this is okay. And we can green light this inductor. I think we green light the inductor, and then when we go over this chip itself, we can double check the schematic the actual values of components around it. So I'll leave that for later. But for now I can just greenlight the component itself here. Then we have P1 is the switch. Which switch? P1? Yeah, so P1, P2, P3, P4 are switch inputs, and they're going to be debounced by this chip. So here the idea is that you connect button that goes between this line and ground. For this I use a screw terminal block, which has let's see, which is one row of 2 pins, and it has manufacturer code that looks like this, and we can go to Mouser and search for it and see what we find. To position 3.5 millimeters pitch, and that means let's see, yeah, 3.5 millimeters UCOM. Do we have any? Do we have? Let's check the data sheet. I want to see a drawing of it so that I can make sure that the silk screen is correct around it, so I don't place any components too close to it. What? This looks like a vertical. Is this a vertical one? This is a vertical one. Damn. That was very nice that I found the fact that it was a vertical one. Because I don't want the vertical one. I want the horizontal one. So that was very nice. You can search for exactly the same ones. Actually, that would be just one product. Search for headers. And let's search for worth. Then we should get something. So wait a minute. This article number here was 69.132.11, and then a bunch of zeros and a 2. 132.11. So 132.11 is not in there. Oh yeah, 1322 could be, no? It's actually 132K. So which one is the horizontal one? I think these two are horizontal ones, possibly this one as well. Right, so these two are the new ones, and this is probably the older one. Let's see. Let's see what this says. This is a horizontal one. To position, and yeah. Okay. So I'm gonna update this switch component. It with the library editor. It's like even if the footprint is correct, these kind of faults, you kind of only see them when you have placed an order and then you get your board manufactured, because the manufacturer will just put whatever component you link to. So what you'll get is a board with wrong connectors, or a bunch of boards with wrong connectors. So it's really good to do this kind of review to find faults like this. Remove that one, and then let's see if I can run this script then. So And also I'm going to push things to Git. It's been a while since I pushed things to Git. Okay, and close this one, and we should be able to update field values, and then we should be able to see this number, which links them to, yeah, that looks correct. Okay, so that was con switch. Which ones we have? P1, 2, 3, yeah, okay. So we have to do like this: 2, 3, 4, 5, 6, 7, 8, 9. No, not the 9. Just 7 and 8 there. So I'm going to green them, and actually, one thing I forgot, which I was gonna check from the beginning, it was yeah, I'm gonna close this one. So I have to check the size of the silk screen around it, basically the size of the component, and just make sure that my footprint is of the same size. So it's 9.2 times 2.45 times 2 plus A, which would be dependent on, I guess, like A would be number of pins minus 1 times pitch. Yeah. So in our case, A should be 2.45 times 2 plus 3.5. 8.4. So 8.4 times 9.2. That's what the component should look like in KiCad. And I'm going to check this footprint. So it's terminal block. Actually, I'll just open the footprint editor, and then I'll check in my document which one it is. So it's terminal block 4 Yukon 1 to horizontal. Let's see. Terminal block 4 Yukon 1 to horizontal. I mean, this doesn't look right, and honestly, I think we just copy this one and we make our own. So copy of let's see, terminal blocks. For Yukon pretty, and then terminal block 102 horizontal, and then I'm going to edit the one that is in my custom library, and also have to remember to update the footprint on the component, I mean, so the field footprint. So I'm going to remove all this crap. I don't want to see all these lines. I think that's just totally unnecessary. Like, what is this? Why did you put something like that? It is so unnecessary. Come on. Yep, and let's remove that line, and then right, so in the data sheet it says it's going to be 9.2 plus 8.4. So this one should be like 8.4. and it's on like start point. So what will be the easiest way to do this? Let's follow the. I was like thinking first there was some kind of midpoint specified here, but I suppose we could just do like this. So we have 8.2. Actually, so yeah, I could do like this. I could make it minus 245. So this would be minus 245, and we'll go to an endpoint of 8.2. Let's see, 8.4 minus 2.45. Right. So 595 would be the endpoint for this line, and then okay, so that makes sense. And then we can make. Then I also want to know it's 1.2. Let's see. So the whole size is 1.4, which is wrong as well. We need to have bigger holes. And it's 1.2 from the middle of the hole to the top part. So here we can say that this is then placed at minus 1.2. Okay. Yeah, that's a bit closer. So we can, it's a bit closer than I thought. So we can make this 1.4 like that, and then we're gonna make this one 9.2. So this would start then at minus 1.4. Actually, here minus 1.4. And set point x is minus 2.45, and 2.45 is there, and then 9.2 minus 1.4 would be the end point of this, like that. So that looks more like the connector that we have here, and then I can just copy this line and then move it there. I can delete this one as well. Let's see. Like that, and I can copy this one as well and just move it here. And about the fab layer, we can move it. Let's see. Let's see. We have fab. And we have courtyard. Okay. I wonder if there is any way to select everything on one layer in KiCad. Actually, let's do like this. So we're going to move the courtyard down a little bit. I'm going to make the courtyard here. Something like that. And we're going to drag this one here. Let's see. What's going on with this one? Like that. That's good. And then this one is back here. that, and then we can just move this one here, and we can drag this line here. I wish there was some way of drawing like a... Can we draw a rectangle? No, it's like it ends up being several lines. So it would be nice if there was a way to draw just a square or a rectangle. Yeah. Okay. And then this this fab layer as well. So what do we do with that? I can just move it around a little bit. Select the ref and select graphic line, and the graphic line there, and then we can move it. We can have the fab layer. Should we have it like that somewhere? Yeah, it's going to be a little bit smaller there. Actually, let's do it like this. Okay, great. Let's remove this as well. Not necessary. Okay. Got a graphic line there, so remove this graphic line here. This is better. So. And then we do like that. And I think it would be a good idea also to add this first pin marker there. You can move this one perhaps here, and then we'll move this here. And I'll just add a line to this silk screen here. It's not really the same size, so no. Damn it. Control Z. Let's see. This one is 112, so we can make a line that is 0.12. Can go like that. Can end here. Och så tar vi 12 där. Yes. I was just starting to speak Swedish all of a sudden. Yeah. Let's see here. Yeah, I'm gonna let this footprint be now. Okay. So this one is green then. Let's see. And the next one is the sensor input, which uses 1 times 3. So let's see where the sensor input is. It's all of these connectors. Oh, also, of course, one thing that's very important is to set this to use the footprint that we just moved to our custom library. So this would be custom footprint instead. Alright. And then moving on to the sensors. And again, I'm going to copy the footprint that the sensor connector is using. So it would be also horizontal. And then we'll update the sensor connector right away so that we don't forget to do that. So I'll open up the library editor, and I'll set this to use right, first of all, what is the actual product that this number is pointing at? Are you kidding me? Is this vertical? Damn it. This one as well. It's quite possible that I mistakenly thought that the only thing that separates the article numbers is the digit at the end, and I probably just copied one and just said 03 there or something. I don't know, or maybe I just picked the wrong part. Right, so it's vertical in terms of cable orientation. Right, okay, yeah, we just need a horizontal one. I'm going to search for Word Electronics and 3 position, 3.5, and we can see here what we have. I think that will be, we can use this one possibly. Okay, so it's this one, yeah, it's just 2. This one, or this one, and this one. So this one is in stock. Let's see what it says. Horizontal, cable orientation horizontal. So I'm gonna use this article number instead. Okay, and then the footprint will be the custom footprint that I just copied to my custom library. Okay, I'll save this, and then I will open up the footprint editor, and I'll update the footprint. So maybe what I could actually do here is open up, I wonder if I can copy from one footprint to another. Let's see if I can. So what if I just select all of this, just press copy, right, and then I open another footprint and I paste into it. Alright, so this worked. So we can just delete all of this and place this one here. Let's see. I need to somehow make sure that this pin is 0. Let's see. Doesn't really matter, but I think it's still nice to have it at 0. It's definitely not on 0. It's on 0.1. So wait. Let's see. Move this one like that. And I think I'm also gonna increase the size of this pad, because it's good to have more copper around it. So maybe even to 3, maybe 2.8. Yeah, I think 2.8 is better. So this one will be 2.8. And then just copy this one and paste it at, let's see, dx is 3.5, so let's move it to 3.5. Oh, it's slightly up. Okay, let's see. 3.5 and up. Yeah, that. Like that. And this would be pin number 3, of course. Okay, and so the length of this line would then be it's so annoying that you cannot enter a length. You have to enter start and end point, but we can see the length there, so we can check here. Okay, let's see. I need to take this phone call, so I have to stop this video, but I'll continue after the phone call.